we will talk about addressing, and this will be an introduction to addressing. So addressing is the logical communication between devices in a network that is inside of the physical topology. Without the logical side of the physical topology, just connecting stuff will not work. As usually, if it just plugs in and play, there is a DHCP server on the network, which is designed to dynamically assign IP addresses. So, there are three types of addressing. There is a MAC address, which is a layer 2 address, which operates at the data link layer of the OSI model. It is 48 bits written in hexadecimal. No two machines have the same MAC address. They are hard-coded into the NIC. Some machines have multiple NICs, as they usually have a wireless NIC and an Ethernet NIC. These two network interfaces, or NIC stands for Network Interface Card, both have their each unique MAC address. The first three octets, or the first three, like digits, however you call it, I don't know what octet is, part of the MAC address is the organizational unique ID. For example, if Realtek, who makes Ethernet NICs, make sure NIC, they will have a organizational unique ID, and this will be the same for all devices that they make. And then the next three octets are your device, or this that is specific to the NIC. Think of a MAC address as like a serial number. However, MAC address can be spoofed, which is a security issue, and is how ARP spoof requests and ARP hopping and like VLAN hopping, not ARP hopping, VLAN hopping. But yeah, those source and destination MAC address are required for a local data transfer. For example, you have one device and another device. If they're connected in the same network, they do not have to go to the router. They just communicate with each other. They use something called ARP, which is Address Resolution Protocol, where a device wants to send a packet to an IP, let's say 192.168.1.100, which is another PC. And it doesn't know the MAC address of that machine. So it says, because it's a logical addressing information. So it sends out a request to the broadcast MAC address asking who has IP 192.168.1.100. And then each device, if it doesn't have that IP, it just discards the message. If no one has that IP, no one sends anything back, and the device that has that IP sends the information back with the MAC address. Now that the device has the MAC address, it stores it in something called an ARP table, and then you don't have to, let's say, find that MAC address again unless you change a network or switch something. Then a layer 2 address is an IPv4 address. They use a subnet mask that is used to determine the network. The network portion must match for computers to talk to each other, otherwise they're on different networks and they can't talk to each other. It is a logical address. It is written in a dotted decimal format, 32 bits or 4 octets. The source and destination part of layer 3 IPv4 packets, layer 2 obviously uses MAC addresses, and it is used by routers to make forwarding decisions. And it is being replaced by IPv6, as we have ran out of IPv4 addresses. Even though there is billions of them, we have somehow ran out of them. An IPv6 address is the new version of IPv4 that is designed to have more IP addresses. It is the layer 3 address. It is 128 bits, groups of 4 hexadecimal digits separated by colons. The source and destination part of layer 3 IPv6 packets is because we ran out of IPv4. And if you think about it, an IPv6 address is kind of formatted the same way as a MAC address. They look almost identical, but you can tell which is an IPv6 address versus a MAC address by just looking at like how many octets it has, because it's gonna have more than a MAC address. Since a MAC address is 48 bits in hexadecimal, and IPv6 is 128 bits in hexadecimal. Mentioned network infrastructure earlier. There are many types of network infrastructure devices. There are hubs, bridges, switches, routers, end devices, wireless access points. So for a hub, it is a layer 1 device. It is a connectivity device. It extends the collision domain. A collision domain is, for example, a collision domain is when two devices transmit on the same media at the same time and it creates a collision. A hub, since it makes no decisions at all, just sends whatever it wants that is received. I think of it as a giant Ethernet cable with ports on it. That's what I think of a hub as. It extends the collision domain, and it shares bandwidth, and it is absolutely obsolete. You do not want a hub in a modern network. A bridge is a layer 2 device. It has two ports. It makes decisions upon MAC. It segments collision domains and is absolutely obsolete. It is a replacement to the hub, so it segments collision domains, but it is obsolete. A switch is the modern of a bridge and a hub, and it is a layer 2 device. It is a connectivity device. It makes decisions based upon MAC addresses. It microsegments collision domains, and it directs virtual connections between two devices / ports. It has dedicated bandwidth, and there is no shared bandwidth, and trunk ports are shared bandwidth. There are unmanaged switches and managed switches. Unmanaged switches are designed to just switch and then you forget about it's even there. A managed switch is designed to have VLANs and advanced configuration that you would not find in an unmanaged switch, and they are more expensive. A router is a layer 3 device that makes decisions based on IP addresses. It forwards traffic to other networks, and it can filter traffic or act as a layer 4 device known as a firewall. A firewall is designed to protect networks and based upon certain rules such as where it's going, where it's coming from, what port it's going out on, what port it's coming from, what IP, what country. It can do a bunch of things. A router can do some of these, but not as much as a dedicated firewall appliance. It blocks broadcasts, and because you do not want those on another network, as a network is a single broadcast domain. Routing protocols to map routes. Routing protocols include RIP, BGP, OSPF, or something. And end devices are devices that generate data flow and can generate traffic. It depends on the primary function. They are known as workstations, laptops, desktops, printers, scanners, VoIP phones, smartphones, etc. A wireless access point is a layer 2 device and is designed to connect mobile devices or devices that need to frequently move around, such as like a laptop that is on campus that people or students use throughout the campus and they just carry it around. That is what Wi-Fi is used for. Perfect example. It's used to connect a device to a network in like a short area where it moves around the entire place. And now for the layers. Layer 1 devices make no decisions as they are basically just a singular cable. Layer 2 devices make decisions based on source and destination MAC addresses. Layer 3 devices make decisions on source and destination IP addresses. Layer 4 devices make decisions on outgoing ports, incoming ports, MAC addresses, IP addresses. They are firewalls. They protect networks and keep them secure.